Tonight, we're going to look way, way up to the very edge of space. We're going to investigate a mysterious, glowing wave that just appeared out of nowhere, grew to an absolutely enormous size, and then vanished, all in a single night. All right, so check this out. What you're looking at is some incredible time-lapse footage from an all-sky camera over Germany. One night, this massive glowing wall of light just appears, followed by these ripples, these waves. It was just a spectacular display. But, it wasn't an aurora. It definitely wasn't a cloud. So what in the world is that? To get our heads around this, we really need to appreciate just how big and, frankly, how weird this whole thing was. First off, this thing was huge. We're talking hundreds of kilometers long. And like I said, not a cloud, not even close. This was all happening way up in the mesosphere. That's super high up, far above any weather you or I have ever seen. This was a whole different ballgame. Okay, so it turns out this was a really rare event. And for something like this to even happen, the physics have to be just right. It's all about something called an atmospheric waveguide. The official name for this is a mesospheric bore. And the best way to think about it? It's literally like a tidal bore, one of those big waves that can rush up a river. But instead of water, this is happening in the super thin air at the edge of space. You've got that sharp leading edge, like a wall, followed by those ripples. Pretty wild, right? But here's the secret sauce. These bores can't just pop up whenever they want. They need a very special set of conditions. They have to be trapped inside a kind of channel in the atmosphere. Think of it like a tunnel or a waveguide. This duct is what keeps all the wave's energy from just shooting off into space. It forces it to travel sideways for hundreds and hundreds of kilometers. So you're probably thinking, if it's just a wave in the air, how can we even see it? Well, it's because the upper atmosphere actually glows. There's this faint natural light called airglow, and it happens in these different layers at different altitudes. When a wave like our bore passes through, it squeezes and stretches these glowing layers, making them light up and dim down. They're basically nature's own motion detectors. So where did this atmospheric tunnel come from? Well, satellite data from that specific night showed something really interesting, a temperature inversion. Normally, it gets colder as you go up, right? But here, there was a layer where it actually got warmer. This creates this super stable pocket of air, a thermal duct. It acts like a perfect lid. And check this out. The data showed this duct was formed right smack in the middle of those glowing airglow layers we just talked about. It was like the stage was perfectly set, just waiting for the main act. All right, so we've got the physics down. Now let's watch the story of this specific bore unfold, from start to finish. Okay, here's the play-by-play. Just before 9:30 p.m. Universal Time, a single wavefront just kind of shows up. Less than an hour later, boom, you've got 3 waves trailing behind it. A little after that, it hits its peak. We're talking a monster, 400 kilometers long. And then, poof, it's gone. It just completely falls apart in under 30 minutes. What a show. And here you can see it with your own eyes. This sequence shows its whole journey. See that first front appearing? Then you can see the trailing waves form as it marches across the sky. These are the real processed images from that night, and they just beautifully capture the whole life cycle. Okay, but hold on a minute. How did the scientists know for sure this was one of these special trapped bores? I mean, there are other kinds of waves up there, things called gravity waves that ripple upwards from storms and stuff. They also make the airglow light up. So what was the telltale sign that this one was different? The proof, it's all in the timing. Take a look at this data. If this were a normal wave moving up, it would hit the lowest airglow layer first, then the next one, then the one on top. You'd see a delay. But look what happened here. At one point, the brightening and dimming in all 3 layers, at 3 different altitudes, mind you, happened at the exact same time. They were perfectly in phase. That is the smoking gun. It proves the whole thing was moving as one, horizontally, trapped inside that duct. So the evidence is pretty solid, but in science, you want to be extra sure. So what's the ultimate test? You try to recreate it, you try to build one yourself. Well, in a computer, that is. So they fired up these really powerful computer models. They basically built a virtual 2D atmosphere, programmed in all the fundamental laws of physics, and gave it that special thermal duct they observed. Then they just gave it a tiny little nudge to start a wave, and they hit go to see what would happen. And you gotta see this. The result was just wow. On the left, that's the real thing they saw in the sky. On the right, that's the computer's simulation. It's almost a perfect match. The model, just using the known physics, totally nailed the look of the real boar. That sharp front, the waves behind it. It's moments like this in science that are just so cool. And it wasn't just a lookalike. The simulation got the nitty-gritty details right too. It showed how the wave would steepen into that sharp front. It created the right number of trailing waves. And get this, it even predicted when the boar would fall apart. The model wasn't just a picture, it was a perfect replay of reality. Okay, so we've pretty much cracked the case of the glowing wave, but you might be wondering, why does this even matter? It's a cool light show for sure, but what's the big picture here? Well, it turns out these boreas are way more than just pretty lights in the sky. They're actually a window into how our entire atmosphere works, showing us how energy gets shuffled around in these massive invisible ways that we can't normally see. As the researchers themselves put it, these things are basically superhighways for energy. They can grab energy and momentum from one spot and zip it across huge distances without losing much steam. They're a really important piece of the whole atmospheric energy puzzle. So when we study these bores, we're really learning how events way down here, like storms, can send ripples all the way up to the very edge of space. And that's a pretty important neighborhood. It's where our satellites live. Understanding this kind of upper atmospheric weather is super important for keeping our technology safe, especially as we rely more and more on space. So this one single event over Germany revealed this incredible hidden dance of physics playing out 100 kilometers above our heads. It just goes to show you that the sky we think of as empty is actually buzzing with activity. It really makes you wonder, right? What other secrets are waiting up there, glowing in the dark if we just keep looking up?